Okay. Hello, everyone. Zach, congrats on the first. Hope you're doing well. Okay. Um, oh, you know what? I didn't completely. I'll do it later. Okay. I forgot to clean up one thing on my OBS, but I'm not going to mess with that right now. Um, we don't have any questions waiting for us in the Discord. $7.50, you got it. So let's do some physics because I wanted to on Saturday, but we had the good problem of being too busy. So, hey, Lucas. One does not simply become first Donomir. Ugh. You got a good few firsts. Let me see. Eight? That's not bad. One becomes first by not becoming first. Wise words. Oh, 750. Gotta pump those numbers up. Okay, small marble with mass m moves with speed v towards large block with mass m. Assume big M is much greater than small m, since it rests on a frictionless table. Yeah, I mean, you can do just exclamation point first, but you have to do your entire name. Scenario A, the marble sticks to the block, and scenario B, the marble bounces elastically off the block and heads backward. Hey Dora, how's it going? Had a study I could potentially follow in a university, which is either called maths or maths physics. Ooh, you kind of want to follow maths physics? I mean, that's what I would choose personally. And there's no harm in changing later if you change your mind later. If you're interested in that, I think you should go for it and do what you feel like you need to do to succeed at it. Got the gold is what I hardly know what Discord Nitro does for you. I didn't know that gold Nitro even existed in the first place. Oh, my Discord is in stream mode right now, so I can't like quickly find it. Is it like what does it do for you? Ranks? Hmm. The only part I mean, okay, Nitro. Actually, wait, no, I do know something that Nitro does. You can post bigger files. You can post videos, and you get some server boosts. So those are some tangible things. But I feel like they mostly try to uh, give you like stupid little aesthetics that I don't care about. Oh, the emote thing too. Yeah, yeah, fair. I don't think it's worth it for me personally. Or I mean, like, If you're on like a big server, then sure, but kind of Discord's monetization has always felt very. I don't know of a good word to describe it. It makes me feel uncomfortable though, the way that Discord like monetizes itself. Like if you want to unlock all the features on a server, it's a lot of money, but they just kind of spread it out among more people with the boosting system. But it's like, man, this doesn't cost you that much money to implement. Well, okay, Roblox and YouTube are no, they're like some of the worst. I mean, I guess Activision is the worst, right? But Roblox censors frick. Oh my god. So physics gets fun the more you get into it. Is that true? 100% for me. Um, Frick is one of the best words I use. um, I played Roblox as a kid, and my friend that I played Roblox with told me he just sold his account for like $400, and he probably could have gotten a lot more for it. Apparently, people are selling Roblox accounts. I need to look into how much mine is worth. If I can remember the password. But yeah, looks like my story of physics is that the physics class I took during university, um, I did not like. They made me not like physics. But doing self-studying on the on physics, doing using more advanced math made me really like it. Explain how physics like now that you have fun with it. Um, yeah, so the thing that makes me really enjoy physics, there's kind of two things, and they both come from the electricity and magnetism reading group that I was doing last year. And I want to do one on general relativity this year. Let me dig up the PDF. Okay, so this is not going to make any sense to you right now. So just don't worry about that piece. But the thing that I really love about studying physics when you know, at least through multivariable calculus, is that you get to yeah, it's rho, Greek letter rho. Math spellbook. Thank you so much for the raid. Welcome in, everyone. Color Cone, hey, how's your stream? Hope it went well. Um, us talking to what is that raid sound alert? I really love those videos on YouTube of huskies just going berserk and throwing temper tantrums. And so the clip itself is much longer, but that's a little bit of huskies just being super weird. I am cut color. Hope you are too. Pretty good. That's good to hear. But yeah, so we are just talking Luke's about uh I mean yeah. I mean mostly on like huskies and I don't know, the huskies seem to have like especially just like super weird personalities. You found one? Okay. Jed is a husky and I'm super weird. Yeah. There you go. Okay. What I was trying to say is that I was trying to explain why I've, as of last year, I found a love for physics that I never had before. Because physics class I took during university were kind of lame because they couldn't use advanced math. And by advanced math, I mean multivariable calculus. Once you do learn multivariable calculus, you can use those concepts to know the connections between all the formulas that you learn about and are just forced to memorize by rote in earlier physics classes. So, for example, you might be forced to memorize the electric fields for different shapes of objects for like an infinitely long rod, for a sphere, for other things. But with multivariable calculus, you can just derive the formula yourself if you just know Coulomb's law. Wait, did I even highlight the right thing? That's basically Coulomb's law. And so what this graphic from an A&M textbook shows is how calculus relates the quantities of electric field, electric potential, which is voltage, and charge density, which is the actual count of charges. Oh, I won't be able to look at an Instagram link. They make you log in. And so this is a volume integral. This is a gradient. This is a line integral. So that a Laplacian. And it's super cool to me that you can just know the connections between all those just with knowing some calculus and vector stuff. The other reason why I really like physics, or like, you know, there's two big reasons. The second one is relativity is just mind-blowing. Why do you have so many symbols that look like an E? For whatever reason, both physicists and mathematicians both seem to love epsilon. Yeah, and so electrostatic fields are always conservative, which is a great property. Once you get into once charges start to move, then you throw that out the window. But other cool things happen. This is Electricity and Magnetism, 3rd edition by Purcell and Morin. I did a whole reading group on this last year, and it was a ton of fun. Yeah, the other thing I really like to learn about special relativity, which it sounds really hard, but you only need like high school level math for it, like algebra and pre-calc. And it has to do with changing reference frames. And there is just the like Lorentz contraction, like it's just mind-blowing to me. This is how reality works, where if you're staying still and you see someone else moving at, you know, something close to the speed of light, if they're holding a rod like up and down, then that rod is its true length. But if they suddenly rotate that rod so it's going sideways, like in the same direction as they're moving, it now looks shorter. And that's the Lorentz contraction. Like, just for whatever reason, once you start moving close enough to the speed of light for relativity to be important, you can see like significant differences in both time and space. And it's just like, I have no idea why, but it's just so cool. Special relativity feels easier to get a grasp on, for sure. General relativity, you need tensors and differential geometry. Yeah, so I've been trying to study mechanics because I really badly want to do a reading group on general relativity and get into that stuff, but my mechanics is so weak that I'm trying to shore it up. How do you even know that's a thing? How do you test that? Yeah, so they don't literally have like, they don't launch a person at like 50% the speed of light or something. But one of the ways that I mean, there are experiments you can set up to confirm it. I'm sure there's many. But the entire reason we have magnetic fields is because electric charges move at really close to the speed of light, or at the speed of light, depending on the medium, and relativity matters there. To an observer standing still, that, you know, say line of charges that's moving gets compressed, and that messes with the field that they produce. And so the field that I measure would be different from a field that someone else measures that's moving along with that, like, you know, rod of charge or something. Basic mechanics is so meek, yeah. let's say I say when things are at the speed of light or close, it's kind of thing where it's close to infinity. It's not infinity. It's a finite number. Um, it's basically 3 with 7 zeros after it. Or wait, no, 3 with 8 zeros after it in meters per second. Um, as far as we know, no, Lucas. Or as far as I know, no. You just break the laws of physics as we know them, as far as I'm aware. You do kind of define similar asymptotic behavior though, where the closer you get to the speed of light, kind of the more things slow down to compensate. So it's not infinity itself, but in the same way infinity is weird, the speed of light is also weird. I mean, let's be like when you take one step, right? I guess, or I'm not sure what you mean with that. What does the Wikipedia page say for the set of curiosity? It must be moving really fast compared to you. Oh, because like time dilation? Yeah, I think that's true. Actually, wait. I believe yeah. The closer you're going to the speed of light, the slower time moves in your frame, or like everyone else sees you in slow motion. I'm sure we could figure it out for sure based on the formulas, uh, in in here too. But I believe that's what happens. Oh my! I'm getting a knock on my door, and I'm sorry. I'm really quick. Give me 1 second. I'm sorry about that. My oven's been broken for over a week. I texted my landlord asking for an update, and rather than texting back, he just shows up and knocks on the door. uh, okay. Um, I've learned one thing about knowing math and chemistry and physics. My guess is based off what sounds like it would be right. This must happen always close to the truth. How to get fast and speed of light is that you check how fast electrons and protons shiver and they move that. Maybe. This is getting beyond me, though. Mix up heat and speed. No worries. And writing negative signs worth mistakes whenever I write stuff out. Yeah, same. Dumb question. What correlations between heat and speed? Um, I think um that heat is just kinetic energy. Like it is heat is literally just the molecules moving, but it's at a very small scale. And it doesn't make for an overall net speed of the object um actually changing locations. It just kind of vibrates in place. As Dora's saying, "Hey Jaden, I'm good. How about you?" But yeah, I think that's how you consider heat. Like it's not actually, it's literally just the vibrations. It is just like a velocity. All right, sounds good, Matt Spellbook. Thank you for hanging out. And in general, I think I should say, like, if you ever just want to raid and run too, that's completely fine. But you take care too. So we can like either gigantify the molecule and make a transport system. Well, the idea of gigantifying a molecule, I think you need to be more specific about what that actually means. I imagine you would have the exact same issue as just anything like it doesn't matter whether it's a molecule or whether it's a bunch of molecules that make up an object. Time is still going to slow down the faster it gets to the speed of light, or like you're not going to be able to break the speed of light in this way. I imagine at least. I would need someone who's better at physics to really like explain why, but I don't think you can cheat the system by making some gigantic molecule with like atomic number 50 trillion or something. Um, Hi again, 750. Want to hear your song? Is it AI generated? Oh, there you go. Okay, that's your song right there. Oh no, your 4060 is dead. Oh, I'm sorry. Um, Lucas, I think that by vibration you're talking about, like, it is just the exact same thing as um any like spaceship moving close to the speed of light. Like if you look at a spaceship moving close or moving at the speed of light, or I guess moving close to the speed of light, and you look at just one of the molecules inside that, you can't say that it's also vibrating and somehow going faster. I've got to imagine that like that slowing down happens at the level of each molecule already. Like I have a hard time like saying exactly why, but using too much RTX, oh man. I mean, color is light, so I would guess so, Lucas. Like color is how our eyes interpret certain wavelengths of light. But light is just color. Or yeah, or color is light. I don't remember. I don't know which order of those words is right, but light is just very bright black. Linux says, I haven't seen you in a minute. I hope you're well. Color is light, but not all light is color. Okay, yeah, that's a good way of saying it. Big internet stuff. Because there's definitely colors that are outside of our, or there's wavelengths that are outside of our perception. What is a shadow? Is there like, yeah, that's a good question because it's just in something that's made. It's just an absence of light, I guess. Like when something blocks the light. Um, yeah, I guess so. I feel like there's a better answer for that. That you could talk about like light diffraction and stuff like that. If I actually knew how that worked. Um, but I think there's some property of materials with like how much light they let through. Like if this is just some like solar panel or something and the sun is up here, I think the light rays literally like bounce off like molecule. A solar panel is a bad word. I should just say like a wall. The light rays will hit the wall and either like bounce off in a way or try to bounce like from molecule to molecule and get through the wall. But I suppose it's just so tightly packed that it can't. The person who wants to defy physics make something less than absolute zero. Hey, Fembox, happy Tuesday. White is very specific to human eyes. Other animals think pink is white. Really? I didn't know that. You know where to start. Oops, I feel like you're gonna be like the villain in a movie, working on some kind of like doomsday machine. I feel like that's where you're going with this. Maybe. Yeah. Depends how you feel. Okay, what's up with number 10? Um, the ratio of blocks resulting kinetic energy scenario B to that in scenario A. Kinetic energy. See, is what triggers speed and heat if I took even closer to what quarks are made out of? Oh god. Beginner stuff. A shadows the impression left by spaces light tries to get to but can't because it's blocked by physical medium. We can perceive shadows because of the spots around them where light can reach. Ooh, nice. That's better than what came to my mind. Human 255, 255 is white. An animal that is colorblind. Then 255, 255. Can animals not see green? I mean, I assume it's a generalization. Like some animals see colors better than others. Feels like a philosophical question. I guess in a way, yeah. Okay, so this book has really confused me with how they're talking about elastic collisions. So they say an inelastic collision creates heat, and heat means that the macroscopic kinetic energy isn't conserved. Um, the thing is, they say the maximally inelastic case occurs when the particles stick together. And my mind always says that means that all the kinetic energy has been lost, but that's not true because I did think that when I was answering some questions previously and I got conned. So I got some of these wrong because of that misinterpretation. Um, uh, I mean, you're asking a lot of questions, Lucas, that I don't exactly know the answer to. Or at least that Google probably provide a better answer than what I can. But you know, like I love that you're like curious about the world and that you want to learn more. So hyper overboard, nice creative word. Yeah. Um, Scenario A, the marble sticks to the block, and scenario B, the marble bounces elastically off the block and heads backward. I just feel like you need more information to solve this, but um, oh, I guess we used one of these previous questions. Which one is it? It's this one, which I had used that I think in the last question right before this one too. And I always feel like you should need more information about this situation to say anything, but maybe this is all the information we need. Um, Now I hate question. Okay, so I did the same idea in 6.9. Nice. Um, I hate that 6.3 uses big M for the moving object, and both of and or actually no, just this question uses big M for the stationary one. Um, so in our This is so hard to translate between the capitalizations for M. Small m minus big M V small m plus big M. V block is 2 big M V over M. M. Okay. And so we don't need that. So I can stop confusing myself. Wait. No, I just did it. Yeah, you're right. $10. Hey, Krim. Nothing much. How about you? And so here we have big M is much more than small m. Is this even what I want, though? Yeah, Krim, that's probably all you need. I'm just trying to work it through for myself, though. One half MV squared. If if big M is much greater than small m, then this is essentially 0. And this is essentially minus mv over m plus m. It should, maybe we should. Like, why don't they tell us what happens after it sticks to the block? Do they stay still or keep going? That's what I don't like. That's why I feel like we need more information. But don't we need to know how much energy is lost per 10 bucks? Like, just minus v? Oh yeah, if we let m like actually go to infinity, it would just be like a minus v there, you're right. That's a better way. Or yeah, no, it's better just say that it's a minus v. So like in scenario B, um, the kinetic energy is conserved. So the before and after is just the exact same 1/2 mv squared. I can work out how much energy is lost. Can I? Okay. I guess we know mv is the initial momentum. I guess is equal to m plus m times final velocity. Make capital M's look like mu's. Yeah, you're being very accusing, Fembox. You can. Maybe I don't want these. I think that's only for elastic. Oh shit, they're asking about the block. I was just looking at total kinetic energy. Yeah, I was thinking that it makes no sense for the reason you're saying. Like the block basically has zero kinetic energy in scenario B at every time. Talos. That I can do with mental math. X plus 420 squared equals 0. X equals minus 420. Hope we're doing well. It's even better because it's multiplicity too. It's double the 420s. Yeah, it's simple mental math, really. Yeah, my pen flipping skills are not good. It's almost a Dr. L level question. It's because in my go live message for today's stream, I just put I was about to try to work it out in my head again, but I put a I forgot that I just can just look at what my go live message was. I put that as my go live message. PhD at 420 maths. These polynomials need to be studied. And the joke with this one is that you can factor it to this. Yeah. I feel like maybe this is a trick question, and I feel like they're just gonna say 1 because in either way, I think if m is much greater than m, even if it sticks, it's hardly going to make a dent. Like I'm basically saying 0/0 is 1, but it's something. It's a tiny bit more than 0 over something a tiny bit more than 0. Well, yeah, that's why I'm saying the ratio is 1. Like in scenario A, the block with mass big M that's much greater than small m is nearly 0, and in scenario B, it's still nearly 0. Will he totally disappointed? I'm sure he's doing a salt of revolution in his grave. No, there's a better joke there. Oh man, what would Lumpy be doing in his grave rather than rolling in his grave? Okay, it's gonna bother me. A new one? Here my mental math skills are starting to fail me. My Wolfram Alpha skills are as strong as ever, though. Okay, well, I won't spoil the answer then if you want to solve it by hand. 750. Wait, what? I don't see the meme number. Or maybe you were just keep giving one that's really hard. Oh wait, I think I know where you're. Okay, never mind. You don't. Well, I mean, no. You probably want me to 171,639x minus 28,980. I bet we're factoring out 28,980. And we've got to do some long division. So you know what? I am doing this by this is going to be terrible to do. Okay. 5. Oh no, that doesn't even. Okay. Nearly 30,000, nearly, I guess, like 5 is probably a good guess here. 0, 0, 4, not 9, 4, 4, 4. I hope I'm 14. Can we fit another 2890 in? No, we go a little bit over, I think. Yeah, we go a little bit over. There we go. 9, 3. I never did subtraction like this. I'm almost forgetting how to do it. This is kind of bad. That'll be a 7. But then we need to make that a 6. That would be a 10, but it becomes a 9, right? Is that how that works? Now, does this go in evenly? It can't. Wait, so damn, you just give me a really hard one then. I assume that 171,639 is divisible by 28,980. Or maybe in the quadratic formula that a meme number crops. I don't. It's like a mystery. I need to know. Where the hidden 420 and or 69 and or some other number is in here. If you distribute a 3 from the 9, into each of those. 420 times 69. Wait, distribute a 3 from the 9 into each of those. Hey, Giev. How's it going? Like, just trying to factor this thing? One seven one 639 over 3. 5 7 2 1 3. 5 7 2 1 3 over 3 again. 1 9 0 7 1. Okay, it has to be 420 times 69. 420 times 69. Okay, yeah. That is 28,980. Okay, I was just doing it with the wrong number. Then how does the other one factor? So, no. But that's a good like a good way to like, I guess what would that be like how many 420s and 69s can you hide in a single problem? Sorry. You really occupy my mind of that, Talos. You're a master of the distraction. Oh, sorry. I thought I was showing my Wolfram. 420 squared? Oh. Hey, Syntax. We were just waiting for someone to pop in with a question. So in the meantime, what we were doing is trying to study mechanics. So I'm working on number 10. What? Excuse me. I did not hit undo that many times. And so I'm about to tentatively say number 1 for number 10 here. Or sorry, I'm about to say 1 for number 10 here, but I'm still thinking about it. Biggest math exam of my life thus far tomorrow. Ooh, good luck, Syntax. Ooh, by the way, before I forget, House is doing those calculus Sundays. And House also in general like takes math questions as well, so um you are looking for more math people. Oh, it's 420x minus 69, 69x plus 420. I'm sorry, my mind's kind of going all over the place today. Good luck for the examiners. Yeah. You study mechanics 750? Nice. Um, oh, what the? Uh, apparently my landlord. Okay, at the start of the stream, I went AFK because my landlord randomly knocked on my door, and I was really mad because they didn't like call or text me beforehand. They just randomly knocked. But apparently, I did get a call. My phone never rang. Okay, sorry. I as soon as that happened, I haven't been able to get a train of thought going. Did I lock and see? Not yet. Um, Gone in the way a lot the past couple Sundays, but yes, we should be doing related rates next Sunday. Nice, nice. Yeah, no, I saw you're having some tech issues on the most recent Sunday one. I hope they don't last. Yep, 750. And so my rationale in saying C so far is that because of this big M much greater than small m thing, um, I think the big block just never gets very much kinetic energy at all. And a very small number over a very small number is just one. Like I'm sure that I'm wrong here and that I'm gonna feel stupid if I actually lock this in, but like I don't know what else it could possibly be. Did they come out like that? I guess so. I mean, okay, if I were to extend this work, like, what am I doing? I guess I'd do the initial 1/2 mb squared equals 1/2. Well, this might not be stupid. Like that. The 1/2s go away. No, this equation is missing something. It's missing energy lost by heat. Is this what I want? Like solve it for heat? But if big M is very big, then this thing is basically zero, which means basically all the energy is going into heat. Um, yeah, but I feel like I know right now it's kind of confirming what I thought that it should just be one still. So I'm still I must not have done something right. I'm sorry, 70. I've been talking about 10, not 11. I had like circle for 10, but I wasn't sure of it yet. Um, who would answer E? Someone answers E to that one, but no, like that one seems fine. It's just being the Earth. Like I don't think that one's so bad. And I guess so. Maybe I'm taking the M much greater than M too literally. Um, sorry, this is A, isn't it? I mean, I think I'm gonna try a little more to keep it arbitrary, but if I still get stuck on that, then I'll go to the um actual numbers. So in scenario A, that's the kinetic energy of, I guess we're saying of the conglomerate. Marble slash block. In scenario B, we look at just the block. So I guess in B, I could use that one previous question that I was using before. So I don't have to repeat work. Now knowing the m's are switched, but the stationary thing is small m. Okay, then I take these two things and divide them, I guess. B over A. Okay, what cancels here? Hey, Freddy. One halves. Oops. Oh, that's where it comes in? Alright, that's stupid. It's not stupid. I just didn't get it immediately, which means that I think it's stupid. Just some mechanics questions that I'm doing. How many more multiple choice do we have? We have a lot more. Wow. Um, yeah, that's like a weird part of the question, Talos, where in scenario A, the block also has the marble attached to it. I assume that we're kind of just ignoring that in part because of this big M much greater than small m thing, but it is kind of weird. Thoughts on electrical engineering? Yeah, since you're in the AP physics, so fun, but I want to do international marketing. I mean, both of those are probably good degrees to get. I I just go with whatever you're interested in, or like whatever you're interested in more. But I think both those could lead to good jobs. Um, okay, let's do some more questions and then I'll check answers, I guess. I've been checking the answers in batches, but oh wait, I need to get a figure. Go figure. Get rid of that. New page. Bam. Okay. I think we once get through these questions, we'll check our answers from. I think I checked 8 and I got 8 right, so from 9 onwards. Okay, so kinetic energy, um, in the same scenario as 11, but they're asking about energy. I think it's just going to all go to heat. I mean, maybe some goes to the earth, but I imagine it's just going to heat. Everybody has got a bunch of stuff for free. It's got about 10 books about electrical engineering. Oh, wow. Model theory? I never heard of it. In a one-dimensional elastic collision, ball 1 collides with ball 2, which is initially at rest. Can the masses be chosen so that the final speed of ball 2 is larger than the initial speed of ball 1? Ball 1... Okay. Can the masses be chosen so the final speed of ball 2 is larger than the initial speed of ball 1? So actually, dude, that same question is coming back again and again. Do I tell it copied? I sure don't. Ugh, I just need to carry this question everywhere with me. Apparently. I need to get a tattoo of it. I remember, I forget, it must have been like an algebra class or something, but in high school, some teacher was joking. Maybe, oh no, I think it was in middle school. I remember the teacher, but at some point, a teacher was joking about if you were to get a math formula tattooed on you, it should be the quadratic formula. And so then, like, the joke became about all the ridiculous places you can get that tattooed on you. But like, I feel like it's kind of a lame formula to have tattooed on you. Like, if I was gonna get a math formula tattooed on me, I want a cooler one. Quartic formula. That would go down like I'm down your entire back, like go from like your neck all the way down to your ankle. um, you have to do Sierpinski. Oh, like you actually do? I've seen it on your like VTuber. That's a cool thing to get. I don't think I'd ever actually want the tattoo for myself though. I know I would just rather like have something like on the wall than on me, but there definitely are some really cool like tattoos out there. Um, so in this scenario, I guess we would want v big M to be less than v small m. Can we make that happen through choices of velocity? So if we want this one to be large, well, increasing or decreasing the mass of big M doesn't seem helpful. So our only choice, I think, is to make small m small. So Vm is big, right? And that, I guess that would mean like you have a bowling ball colliding into like a marble. Which, if something was going to do that, I guess it'd be a scenario like that. Um, Actually, maybe we'll do the comparison. Like if m is much smaller than big M, what happens to this one? No, actually, I don't think a marble, or no, a bowling ball colliding into a marble. The bowling ball will just keep going, wouldn't it? The marble will come along with it. Yeah, because I feel like here I'm just going to get V. If the small m is insignificant, then it's basically just V, because it's going to be big M over big M. Well, here it's 2V though, right? So maybe you can do it? I don't know. Maxi, the question I had was the downwards Lowenheim-Skolem theorem. Oh my god. I have no freaking clue, Maxi. They finished. And hey, Tyler. Confucius say, many man smoke, but who man... Wait, what? Oh, I get it. Few man chew. Ugh. I think we had to work out what it sounds like. Famous just putting on a light show for us. Don does disco. So maybe I guess the scenario that I'm thinking of is man who fart in church sitting on pew. Oh my god. I think instead of the marble bowling ball thing, I'm getting a little tripped up on that. Maybe we want blocks of equal size but different masses. Um, yeah, okay. I think small mass for ball two, big mass for ball one. We have one big ball and one small ball. I'm locking that in for 13. Just finishing up all my Excel courses and you have a graded project. Nice, nice. Mass M moves with a given speed and collides not necessarily head-on, elastically with another mass M that is initially at rest. Which figure shows a possible outcome for the two velocities. Velocities are drawn to scale. Ooh. Well, I guess we should get a handle on what the magnitudes should look like. They're equal mass. But, dude, we need this thing again, right? Well, this is head on, right? Ooh. Well, no, the magnitudes. This should hold true for the magnitudes, though, right? Because it's just based on conservation of momentum. Gave me 100 from Excel words and no stress. Nice, nice. You don't think I need it? Hey, Phobos. It's perfectly symmetric if you change our stream to one where both are moving equally fast. Oh, like the center mass frame? Yeah, okay. I think it was still true for the magnitudes, but maybe that is the wrong thing to think about. Yeah, the reference frame like change paths if they're not hitting head on. Physics is confusing, yeah. Um, Drumcat Envy. Oh yeah, you know, I did get gifted an Ivan sub, so now I can do the Dick Hart emote. Gotta pay to play. Easily why and precisely why physics is science, math is more reasoning, whereas physics is logic. Ooh, that I don't agree with that word choice, but there's definitely a big difference between the two. Yeah, I think physics is more like intuition, but math is like as logical as logical gets in my mind. It says I'm studying logic. Yeah, Maxi. That question is crazy. He uses a lot of terms that I've never even heard of. Do I need to like? I think the text of the chapter kind of it didn't talk very much about two-dimensional collisions, other than you need more information about how they collide. That's kind of all they said about it. I wonder if CM frame is a helpful thing, though. Well, no, I don't know. Ami is calling C. Uh, yeah, it's probably like hard undergrad mechanics, Freddy. And so, yeah, if you're in AP physics, you have everything you would need to like do questions from this book. Hmm. Yeah, I'm just trying to decide right now whether like we want equal size vectors or different size vectors. Um, I think we want different size vectors. The masses are the same, yeah. Wait, okay. What does my thing say about if I know this is for 1D, but if the masses are equal, Oh, funny. The first one just zeroes out. And the second one just gets all the velocity. Basically, all the velocity would just go into the second one, and the first one would stay still. Okay, so I think with respect to that, um, I think C isn't possible because this is a head-on collision, which would be 1D. And according to the formulas I just looked at, that first arrow shouldn't exist. And so I think they should be unequal lengths, which will just really leave E. Yeah. I feel uncomfortable that they gave three equal length ones, which makes me feel like psychologically it should be equal length, but I think it's not. Um, Final one has speed to the right. Oh yeah, that's a nice way of thinking about it. Okay, so let's check from number 9 on. Where the masses are the same, the sum of velocity vectors has to be equal to the starting velocity. Yeah, like that I like that. Um where like the y components of these would cancel and the x components would add up to the original velocity. Yeah, I think C shouldn't be it because that's a head-on collision, and if it's head-on, then the first smash should just stop, I think. Okay, so 9. Uh oh no. Oh wait, no, yes, I okay. 9 is A. I got 9 right. Human balls near the same speed before it's after. Yep. 10. E. And I said E. Thanks to some coaching. 10 is what I was stuck on for the longest time. 11. B. And I said B. Noish. 12. C. Noish. Do they say anything about kinetic energy going to the Earth? Essentially no energy. Okay, yeah. Not literally zero, but basically zero. Yeah, it's more. Where's the math? Right now I'm just doing some physics studying because I like it. 13. Yes. Yes. The reason I thought. 14E. A. And by A, I mean E. C has more kinetic energy out than in. Ooh, yeah, okay. I was thinking about it only with momentum, but yeah, the kinetic energy. A nice way of thinking about it too. Choice C doesn't satisfy conservation of E. Yep. Okay. It is as much as I love math. I mean, I do math studying too. I've been doing some linear algebra, but you just happen to catch me at a time that I'm doing physics, so there you go. All right, so let's get 15. See the math? This is math. Really just see how difficult it can make the phrasing so confusing as possible. I feel that about some of these questions, to be honest, where they're just weirdly phrased. And I would get them right if they were phrased differently. Paddle hits a ping pong ball. Paddle moves with speed v to the right. Ping pong ball moves speed 3v to the left. Collision is elastic. Paddle moves speed v to the right. Ping pong ball moves speed v 3v to the left. Collision is elastic. Not freaking journal. Thank you, $10. When I hide and unhide that window, it sometimes gets stretched out like that, and I haven't been able to figure out why yet. It's really annoying though. The resulting speed of the ping pong ball. All right, Talos, thank you for hanging out. Good luck with your very normal job. um, I'll see you later. Okay, paddle. I think this is the initial, like all of a sudden it's the original thing. Moving to the right with V. The ping pong ball. That's very large. I mean, they're supposed to be large, but anyway. Moving to the left with 3V. I assume the paddle stops right after hitting. We'll define the right as positive, I guess. Oh, is P paddle or... Okay, P is paddle, B is ball. Uh... MB... VF, we'll say. So first let's just isolate VF, which occurs. 3mb over mb v, right? Um, and so we do assume the paddle's much more massive than the ping pong ball. So doesn't that just delete these? Well, no, wait. Let's split this up into different. What the hell? This makes no sense. If we try to apply it here, like this is just a big number. It's a big number divided by a small number, right? And this is like a constant, it's always there. Hmm. Wait, the collision is elastic. Is it bad to assume the paddle stops moving? Is that what this doesn't make sense? Should I pretend like the paddle was just like there's no one holding it, it's just flying through the air? That's not exactly how ping pong works, but I think we might need to consider it like that. Um, and so I guess we're gonna do plus and let the signs work themselves out. Okay, so then we have two unknowns, and so we need to bring energy into the picture. Yeah, the elastic part, I guess, makes it seem like the paddle should move backwards too. Like, that kind of implies that people are just like throwing their paddles though to hit the ball, which that would be a cooler version of ping pong, a lot more impressive, but probably a little unrealistic. Okay, so we have two equations, two unknowns. We want to solve it for VB. No V, yeah, VB. No hands ping pong. Yeah. So let's solve. Which one do we want to plug into? Uh, I guess let's solve this for VP. in terms of VB and plug it in here, this is going to be a little terrible from the looks of it, though. Let's find out exactly how terrible. Over P equals VP. Sure. And so then we take that and that. Oh God. What are you doing to me, Morin? This is a physics crime. Yeah, you want me to square this? You can make painting with messages of gamma and pi functions. Large opera. I definitely see people make like Desmos art. Approximate V since MP is huge. True. Um, yeah, I guess that'll simplify this annoying thing in some way, right? Like we could basically delete that piece of it and then cancel the MPs. I don't think it's helpful anywhere else. But that is pretty helpful. Um, so it's become V minus VB squared. Yeah. That's better. Yeah. We probably are gonna end up deleting that, but maybe let's not do it quite yet. Maybe we shouldn't delete it because we don't know what V is. Um, I feel like more is gonna come out with a way easier way of doing this. Is this? Would it be easier than center mass frame? I'm in too deep now, but I bet this is yeah CM frame problem. Okay, let's see what answer we get from this terrible thing. If it doesn't look quite right, we'll try CM frame. That's a plus. Very popular meme a while back. Basically, math graphing calcs with mapping pi cows for introducing variables. Oh, nice. Yesterday, ping pong is the fourth most gambled upon sport? Really? Did they say, like, what countries? Most gambled? Like, I assume there's certain countries that just, like, love ping pong. I've seen news articles about someone in Colorado betting millions. Wait, let me. This Yahoo article doesn't even mention ping pong in their top list. Ah, okay. It's an interesting stat, though. I wouldn't expect for, like, ping pong to rank that highly. We're solving for VB. It's a quadratic? Oh my god. What's the CM frame way? This is too painful. What's the equation? It's M P X P plus M B X B over MP plus NB. I mean, I guess we care more about the velocity, right? Saw in a recent John Oliver segment on sports betting. I guess ping pong is popular among gambling addicts because of the short matches. Oh, okay. That's fair enough. Okay, if that's cut that, paste that. That's the position of the center of mass. The velocity of the center of mass is the time derivative of this. My B's and P's are kind of blending together. Only I can find a way to do that. But the ping pong, or the paddle has V to the right. The ball has 3V to the left. These are vectors, so we worry about signs. NP minus 3 MB over NP plus BV. Okay. That's the velocity of the center mass frame. We take that and we subtract it off each of the velocities? Question mark, I believe. Yep. So then in CM frame, paddle is v minus, well, okay, v minus vcm. Yeah, of course, duh. Um, how does this work? I need to look back at their like 3-step thing. You just reverse the velocities. Wait, I'm trying to work it out in my head, and it's too simple. All I'm doing is doing a minus VCM and then a plus VCM right after. That doesn't make sense though. Okay, wait. Let's be more thorough. MP V minus VCM plus MB minus 3V minus VCM. This is a positive quantity. And the center mass should be moving to the right, at least when they're colliding. Or when they're like going towards each other. So their velocity is just reverse in the center mass frame. So we just stick a minus sign in front? And what am I doing with this? There needs to be an unknown. I guess it's this. Well, they have the same speeds they originally had. So in the CM frame, the ping pong ball goes in with 3V and then out with 3V. And so don't I just need to find the velocity of the center mass frame after they collide? And add that? Or I guess... Hey Viv, it's been a minute. You've been well. I want to simplify the expressions. The paddle has much more mass than the ball. Doesn't this just wipe out to just V? Because MP plus MB is basically 1 for a very small MB. And this thing over here is basically 0. Oh my God. I don't really know A. Or I don't know. How many A's is that? 5 A's? You could be quintuple A, I guess. Final velocity or the final velocity of the ball will be 4v to the right. I guess so. But how would I know that the what am I trying to say? I know what I'm trying to say. I want to figure out this center of mass frame way that the book suggests of approaching some of these problems with, but it's just kind of weird. Oh, I guess maybe that's what they're saying. If the paddle is much more massive, then the center of mass is basically just the paddle. I stopped doing the bash because it was too painful. Well, okay, it's V to the right before the collision. How do I know where it's how it's moving after the collision? I guess that makes sense. I don't know. I wish I could just like get it for from an equation though. I don't really. Oh yeah, that two cool formulas. I mean, that's initially at rest though. If I'm in this center mass frame though, no, I don't know. Here's another one that's foundation. Oh, I guess. Oh, okay. Well, yeah, that's a fact. And apparently, I did that earlier, and I just didn't remember it. Okay, so okay, oh, okay, that just makes it easy. You're right. um, in the CM frame, which is basically just the paddles frame, the ping pong ball is moving with speed 4v towards it, and then after the collision, it moves with speed 4v away. Oh, but no, my question was still, why does the like it makes sense the paddle just keeps moving this forward the same v, but like how do we know that if it's not obvious though? Yeah, so like 6.2, I guess is basically the same question. We're like, all right, I think that relative velocity thing is going to be the same argument, but you still have to know that like the paddle has speed v after. Which I guess I've done that intuitively before. All right, fuck it. I'm done thinking about 15. Hey, Central. Okay. Um, what might be the height? Am I winning? No, I'm getting stomped by Morin. I'm getting completely outskilled. But why be the height above the base? The center of mass of a holocone. It's hacking you. Morin is aimbotting. I was lagging. Let y be the height above the base of the center of mass. Wait. Okay. So y is somewhere above the base. That is the position of the center of mass. There's more mass at the bottom than at the top. Okay, I mean, that one doesn't seem too bad. Maybe I'm gonna get conned here too, but if there's more mass, wait, it's a hollow cone. It's a hollow cone. There's still more surface area at the bottom though, but it's also more spread out. That should, well, yeah, that should make it even. That should drag it away even more. No, wait, yes. Oh my, oh, god damn it, Morin, I hate you. It would be so much easier if it was a solid cone. No, I think okay. Well, the cone is hollow. I'm happy to integrate a bunch of rings. The average, the center of mass for a hollow cone. There has to be a way, like, hmm. Okay. this is one where we can think about each concentric ring. Each ring has a center of mass right in the middle on that axis of symmetry. And so we can take the center of mass of those centers of masses, and I think they're all this. I guess the rings at the bottom have more mass if we're doing a uniform density. So I think it is weighted towards the bottom still. So I think it's still in the bottom half. Because this is essentially equal to a non-uniform like rod of mass with less mass at the top and more mass at the bottom. And the center of mass should get dragged toward the bottom because of that. Okay. And I think that's basically what you're saying there, quintuple. Mass 2m moves rightward with speed v towards a mass m that is at rest. Hey, Jesu. Mass 2m moves rightward with speed v toward a mass m that is at rest. What is the speed of the mass 2m in the CM frame? CM is equal to okay, so center mass is, I guess, weighted a bit towards the 2m. What is the speed of the mass 2m in the CM frame? Oh, the velocity of this center mass frame. Like the other block being at rest makes this simpler, right? Because this should just be 2mv over 3m, which is 2/3 v. Because there would be a plus m0, but who cares about that? Okay. So then that's the velocity of the center mass frame. So it should just be 1/3 v. Because we subtract off the center of mass frame is moving to the right. The 2m mass is moving to the right. So I think it's v over 3. Okay, 18. A heap of rope with mass density lambda per unit length lies on a table. You grab one end and pull horizontal to constant speed v. Shown in figure 6.5. Assume the rope has no friction with itself in the heap. The force you must apply to maintain a heap of rope. Oh my god, dude. I read the words, but I didn't understand them. A heap of rope with mass density lambda per unit length lies on a table. Grab one end and pull horizontal to constant speed v. Force you must apply to maintain the con. There's no friction. You don't need force to maintain a constant speed. Uh, am I gonna get moroned if I just say it's 0? Oh my god, I'm gonna get moroned by morin? Dude, that can't be a coincidence. That his name is one letter away from moron. Uh, why would you need force to maintain a constant speed if there's no friction? Oh, because the mass is changing as you pick up the rope? Bruh. That could be it. Yeah. Because when the rope is laying on the ground, I guess you would consider it as not contributing mass. Um, okay. So you can define, or you can express force as the change of momentum with time. And if mass is variable in time too, you get a product rule. Okay, MA plus DMDT V. Newton lied, force isn't MA. Okay, now this piece is 0. That's the part where I got mourned in my first, with my first instinct. But we still have this piece. Um, mourn is now a verb. It's a great verb. So, so you don't like to go and get mourned? I hate getting mourned. Um, hey Obi, I'm doing good. How about you? Finding a throwing projectile approach the length of the projectile traveled is maximum, as in like arc length. My instinct, my guess say 45 degrees, but that's probably I'm probably getting mourned. Meh, that's better than bleh, right? It's not 45. Interesting. 45 is like the best horizontal distance, I guess, but that's an interesting thing. Oh, yeah, that's gotta make it a lot worse if you actually like know people who are affected by it. That definitely like weighs on me too. But well, I do know two people, I guess, who work for the federal government, but I haven't caught up with them in a minute. From Maryland? Oh, true. Yeah, yeah. Right. The highlight thing that doesn't work anymore. Think you're gonna try to transfer them to YouTube or just gonna let it go? All right. See you, quintuple A. Thanks for hanging out. Fun is relative, but I'll try. Turn down 30 plus hours a day to YouTube, which is doing wonders for my algorithmic position. Probably annoying. Yeah. Yeah, that's like a whole project. That's another reason why I just dual stream it to YouTube because I used to just transfer all my VODs over manually, but that was just such a big pain that dual streaming it takes care of that for me. Two accounts? Oh yeah. I mean, I do have two like outputs set up, like one for the game YouTube also that I've used for like Factorio. It's still annoying to deal with, like, but you can. But yeah, I theoretically could stream to all three at once if I wanted to also. Yeah, no, it's still it it's still a whole thing. I definitely don't blame people don't want to deal with it. Um, so we're wiping that term out. The mass, I'm pulling at the horizontal speed, so the mass is increasing at a horizontal speed. Um, DMDT. Isn't that the thing Joe Rogan always asks about? Or like DMT? I don't know what it actually is. I just know that's like the meme with him. I think so. I feel like whenever I hear Joe Rogan mentioned, someone always like says, "Oh, you ever tried DMT?" Apparently, he asks that a lot. I never actually listened to an episode, to be honest, but as far as I know, that's just like the meme. Um, okay, so the mass in a small amount of time DT, we have an increase in lambda v dt, or I guess like maybe dl or something. I don't know if this is like the most helpful way of saying it, but oh wait, oh that's how you say that. M is just equal to lambda l. But dl dt I think we're gonna say is the constant v. It should be equal, which means the force is lambda v squared. Do those units unit out? They do. So here's your group stats report. Ooh, nice. You feel good about it? Alright, so lambda v does not even have the right units. Lambda LG. Lambda LG. Does have the right units. Lambda v to the fourth over GL, I don't probably does have the right units. It's only v that doesn't have the right units. I think I showed it's lambda v squared. I might get more end on that, but mid 60s percentage. Second highest grade in the UK. Oh, okay. Thank you for providing that frame of reference, because a mid 60s in America is not a very good score. No, it depends on the class. There's some insane classes where you would be happy with that. You saw the incorrect legends as I put the transmission in. Oh, nice catch. What you got on YouTube was showed essentially all the effects of the drugs while discussing the potential issues. Was a good channel. Oh, nice. Yeah, to be honest, I have no clue what that's supposed to even do to you. Sitting special for the top rating. Okay. Ooh, wow. All right, there's only two more multiple choice questions. Wow, it's already been 2.5 hours. No one's had a question today so far. Interesting. Last stream I was like slammed. It's kind of like funny where it's not very like even, I guess. The questions that I get. They're hand at a fixed position. You hold one end of a heap. Actually, you found 19 really hard. I'm just wondering if I should check the answers up to 18. Because it seems like me being right or wrong for 18 is going to inform my answer for 19. I think let's do that. So I checked up to 14. I think let's check 15 to 18, and then we'll look at 19. I don't know if that counts as cheating, but I think 18 is going to be helpful for 19. Okay, 15 is D. Good. Uh, 16 is D. Yeah. Yeah, and I got the argument the same. 17 and then 18. I'm trying not to scroll too far down. I'm trying to avoid the spoiler for 19. 17 is B. A, okay. And by A, I mean B. 18 is C. Oh, I actually got that right. Okay. I'm not going to scroll any further down. Like, you can just barely see C at the bottom there. But if I scroll it down more, I'm afraid I'm going to get a spoiler for 19. Switch over to some more polynomials. Nice. Famished. Yeah, if they hand it a fixed position, you hold them onto one end of a heap of rope with mass M. and then let the heap fall. Heap of rope with mass M. A heap of rope. Okay, so it's like, I guess the same thing as last time, but like, this is just like a big tangle of rope, and this up here is the same as the rope. So it is another variable mass, I guess, maybe. Well, it's always hanging though. We're not lifting it up off the table. The rope has no friction with itself in the heap. Eventually, the heap runs out. You are holding a vertical piece of rope with mass M. Is there any time during this process when the upward force you exert with your hand exceeds mg? Ooh. Yeah. You're losing potential energy here. If this is the ground, then this configuration has more potential energy than this configuration. And if you have a change in potential energy, that means work was done. Which means something. Does that mean the force was more than mg? I guess that's maybe the question. Or can we think about the center of mass? Wait, like if we could concentrate this thing as a center of mass, say there, it would shift down to like somewhere there once it's all entangled. Can we think, does that help us? Does that simpler version of displacement do anything for us? I guess it would be the distance in force times distance. Question mark? Um, hmm. Does it exceed mg though? My mind is telling me yes, but my body is telling me I have no clue why. Or it's more like my body is telling me yes, but my mind has no clue. I said that backwards. If potential energy changes, does that mean I have to do more than mg? I feel like that's the key, though, to think about the energy of this thing. I guess I think I'm. Am I saying yes? I'm mostly about like a free body diagram. Or I guess maybe you want to draw it higher up, but like if you have a free body diagram for the entire rope and like, just cut off my hand, this is MG, but that thing is going to become not MG once the rope is all the way extended, because you're missing that piece of the rope. You did a free body diagram? I guess you. Hmm. What about that free body diagram? I I want to say yes so badly, but I really can't justify it. But like the energy changes, but I don't know that that means you exerted force more than MG. The mass isn't changing because it's always hanging. I guess parts of the rope are accelerating downwards. Would that mean hmm, maybe that's the key? Maybe as the rope is unfurling, you need to account for the acceleration of that little bit of the rope downward. When he says the rope has no friction with itself, he's assuming the heap will fall with acceleration g. Uh, I don't know what I was thinking in terms of that, to be honest. I don't know how to get it. I don't know what the helpful free body diagram here is, if there is one. Hmm. Okay, I think about it intuitively, where if you have a rope and you unfurl it, once it gets like fully stretched out, it like pulls a little bit extra, and you're like, whoa. And I feel like that's when your hand would exert more than MG. Intuitively. Um, and so I guess maybe that's why my mind is telling me yes. My body is telling me yes. Whatever I said before. And the best explanation I can think of to actually justify that is what is it? The rope has some momentum, I guess. Okay, yeah. The rope has momentum as it unfurls. Like each section of this rope has momentum. And if force is change in momentum in time, well, no, it's not a good argument either. That doesn't mean that's more than MG. Maybe it is. Maybe there's an. Momentum has definitely changed. And I feel like that's an extra force beyond the force of my hand holding up the heap. Like I feel like this. It feels stupid though because the this definition of force should also include the force of my hand holding up the heap, but I'm saying it's separate. I guess I'm talking about two different forces. One of them is just mg, the other one is however the momentum is changing as it unfurls, and I stop it. Importantly, like it's the stopping that produces that. I don't know. This is it doesn't feel like a satisfying argument, but I'm pretty sure it's yes. I'm having a hard time explaining why. I think I'm gonna lock yes in. I'm gonna. I think 20 is the last multiple choice question, so I think I want to figure that out before I check the answer. The linear mass density of dust on the floor. It is accelerated. Equals 0. So we only care about change in mass. Mm, 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 mm. This mass here is a function of time. I was about to say that the final answer shouldn't depend on big M, and that only that shouldn't depend on big M. That depends on big M. M plus lambda x is the mass at any time. Now the mass is changing. Mass is changing. We have an acceleration. A constant acceleration. And so it's going to be lambda times a change in x. Well, now how do we dx dt? How do we deal with dx dt? I don't like dx dt. It's a velocity. Displace it under the rock. True central. Dx dt is velocity. Do we want the good old chapter, I guess 2, like vf squared minus vi squared is 2ax? Vi is 0. And so vf, which is also dx dt, is root 2ax. This is stupid, though. I don't like that. No one likes that. Oh, wait, we want... maybe we do like that. Because it's lambda dx dt times v, but dx dt is just v, so we get a v squared, and it actually doesn't look that stupid, right? There's no 2's anywhere in these, though. Does it go away? Let's find out. ma plus lambda xa plus lambda. Now that's v squared, which is 2ax. So those combine. I'm feeling less good about this because this is not going to match any of our answers. So I nearly have that. Oop, I nearly have answer C. I just have a random 3. That rhymes. The right answer in a different form. Really. Oh, what? Okay, it's E. I guess I was simplifying it too much. Oh, they do give us V. I missed that. Okay, I thought V wasn't a given. That's why I wanted to get rid of that. Okay, thank you for pointing that out. All right. I think 20 was the last multiple choice. Let's check our answers. Number 19. Oh, wait, actually, this mark is kind of interesting for 18. I think I just got a delivery. Well, like it sounded kind of like rough. Like the person who delivered was kind of angry. Okay, the answer to 19 is yes. Change the momentum of the pieces of the rope. Okay, I did think about it correctly. Okay, it is a different force. Okay. Wait, really? The answer to 18 carries over? I thought 18 was unrelated the more I thought about it. Okay. 20 is E, and I said E. Oh my god, using the dot for the time derivative. Okay. Noish. That's the multiple choice for number 6 done. We could do some problems. We could do some linear algebra. I don't know. We've done the first 6 problems. Hey, Reaper. How have you been? I did see the Atwood's machine there. Working to death? Oh, I'm sorry. I'm doing pretty good. It's been a bit of a weird day. Where like I started the machine, my landlord just kind of like randomly knocked on my door, and I realized after that they called me, but my phone like didn't ring. But other than that, it's a nuclear demonstration. Thank you for the follow. There's 25 problems. It's a lot of problems. We're not going to do all of them. We can keep going with physics, I guess. We do linear algebra on Thursday. So I kind of don't mind either right now. Oh, a hollow shell. Okay, more about asking about these hollow objects. I guess that's the formula that we want. We could also think about it like the cone. I think there's like a related rates way of doing this too, where like what change if you have a change in height, what change I guess in circumference do you get is what you would care about if you do it in rings. Or I mean if it's a uniform mass distribution, I feel like I've done this exact problem probably, but with like E and M, where these are charges. Maybe not for. I guess they're not like center mass for. Maybe that's an equilibrium point where the force is zero. Well, it's funny. I wonder if that's the same thing. Huh. Um, could we just spherical integral it up? I bet there's a much easier way of doing it. But you're still sitting here at work, so I'm gonna head home. All right. How many pages problem 7 took you? Because of Calc 3? Ugh. All right. See you in a few. Actually, this is not a double integral. Or a triple. This is a double. It's a shell. What does that mean? Hmm. No, let's not try to do a crazy double or triple integral. Let's try and be smart. For once for once in our lives, let's try to be smart. This is a terrible drawing. I said be smart, not be an artist. How do you draw a hemisphere? Okay, let me do a different perspective. This is terrible. Uh, absolute shit. Okay, sure. Um, it just looks like a boob. I, let's be real. Okay, well, it looks less like a boob if we draw in a couple of radii, though. Um, I guess what I'm trying to think of is I want to think of these as rings. How would I express those rings? A circle is just a bunch of rings stacked on top of each other. Okay, yeah, so we need to, okay, let's actually get a two-dimensional cross section here. That's better. That's what we want, I think. Because we know that is R. The radius of the ring is that piece of the right triangle. So the circumference of the ring is 2 pi root r squared minus y squared. Pythagorean theorem. And so the mass contained in this ring, I don't know, I feel like I'm just talking about, I feel like I'm speaking weird. Or like, if you let, instead of being a truly like infinitely thin ring, but or just give it like a little bit of thickness. Uh, it's going to be density that I'll call sigma, 2 pi Edison accounting problem. I can try with it. It's not my best, but I might be able to figure it out. Times a small change in thickness, I guess dy. Is dy the right dimension? Yeah, I guess so. I think. No, probably d theta. D theta feels better, right? Okay, but that's not a distance. Hey, Suna. It needs a differential. It could be RD theta. That comes up a lot. That's going pretty good. Just getting my ass handed to me by this physics, by this physics textbook, like usual. Maybe homework you didn't do all day. This one probably isn't that hard. I'm probably gonna mess it up here, but at least for me, it's not easy. I guess I should say. But I think someone who's actually like this is a relatively basic one. Oh, I just saw the thing that Obi posted. I'll look at it later. Step one: get DMT. Okay, let's throw this out again. DM is equal to sigma. It's like one of those that, yeah, exactly, Suna. Um, Sigma, the surface density, RD theta, RD phi. Maybe. What does this give me? What is the vector R? R. Wait, this doesn't have units of mass. Yes, it does. It's mass per area, distance, and distance. So we just get mass. The R is just a, like, is that just a constant capital R? This is one where I would really like to have an example, but but like in this, for the sake of being brief, doesn't really give examples. um. Ooh, okay. Edison asked his question. Let's take a break from this problem. Okay, we can probably do this. We have up to 5-digit numbers. Um, I guess let's consider, um, yeah, I guess we should consider, well, no, maybe we can go straight to 5. 1, 2, 3, 4, 5. Exactly 3 sevens. So we could think of this as, how can we think of this? Seven, seven, seven. We have 9 options here, 9 options here, because there's 10 digits. But we have to be careful of zeros. So I do want to consider different digits to make life a bit easier. Now it's going 81 times 50, that times 5, choose 3. For 3-digit numbers, we just get 1, right? 777. 4 digits. Oh, this is still, like, we have to be careful of not counting a 0 in front, because that's a 3-digit number. So, interesting. We have 4, choose 3 ways to place 7s in these 4 slots. The remaining slot, let me do it like that. The remaining slot, in theory, has 9 options. But I guess we need to subtract the case, or all the cases that involve. Wait, I guess we're trying to throw out. Is it only one case? Is that the only case for 4 digits? So we just do a -1? Oh, I mean, in theory, we're just doing a +1 from up here, though. But okay, let's just leave that. There might be a way to combine this and not have to consider separate cases, but I'm not going to feel confident if I try to cut straight to the chase. 1, 2, 3, 4, 5. Here, there's 5 choose 3 ways to place your 3 7s anywhere here. And then theoretically we have 9 choices for the remaining digit and another 9 choices for the other remaining digit. Except we need to subtract off 0, 7, 7, 0, because that was counted up here somewhere. And we need to subtract off that was counted up here. Is there anything else? I don't think we need to subtract anything else. Wait, you think it is 81 times 5 choose 3? Oh wait, no. I have more. No, 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 no. So we need to subtract off one of this case, but then we need to subtract off 9 of these cases. 10. Yeah, sure. Official nav, welcome in. Leading zeros just count as shorter numbers. I guess so. Maybe you can just go with 81 times 5 choose 3. I'm curious to see if these work out to be the same. Yeah, I guess you're right, Fembox. Maybe you don't need to be careful of zeros. Choose 5 comma 3 times 81. So Fembox's answer is 810. My answer, I think I mean, if we're both right, it should work out to be the same. 5 choose 3 minus 10 plus choose 4 comma 3 times 9. That's not right. What the hell? Oh, I forgot the 81. 836. No, I wonder why it's not right. Oh, I know I'm overcounting because I need to subtract off. Maybe I need to subtract off. No, I don't know. I don't. Okay, I don't know what I did wrong here. I really feel like Fembox is right though. I think I think just more simply put, we have 5 slots. We choose 3 of these slots to be 7s, so that's where the 5 choose 3 comes from. And then in the remaining slot, let's just say like we have our 7s in front. We have 9 choices and 9 choices. So times 9 times 9. And we don't care about leading zeros because that's just a 4 or 3-digit number, and we also want to count those. So I like this answer, which is 810. So I hope that helps, Edison. Official Mab, feel free to let me know what your question is, or you can put it in Discord if that's easier. Got some bearing stuff. Okay. The book answers. Yeah, they're really tricky, Edison. Okay. North, east, west, south. So the first vector. Okay, how these headings work. Oh man, which way does the angle go? Is this 71.8? I'm a little bit rusty on these. Or do I measure it from west down to south? I think from south to west. Yeah, from south to west. I think I'm... That's right? Okay. Thank you. It's just been a little bit. 71.8 degrees. And so that vector has length 10.3. And then east, we have 67.8. Okay. So I want to break these things up into components. Yeah. And so I want a component along the west part and a component along the south part. So I guess we can draw, there's a couple different ways you could think about this, but if I want to get the south part, then I'm going to draw this right triangle here. And we know the hypotenuse. I'll draw this separately. We know the hypotenuse is 10.3. That's a right angle. This is the south part that we want to get. And this angle here is 71.8 degrees. So we can do some trig here to figure out what the south component is. Sorry, I should say cosine of 71.8 degrees is equal to adjacent s over hypotenuse 10.3. So then the south component is 10.3 times that cosine. And we'll plug that into a calculator in a minute. Let's get the west component first, though. Well, actually, no. No, we can do the calculator part first. Remember when you do these, that your calculator is set in degrees, not radians. 10.3 cosine 71.8. My calculator is Wolfram alpha. Okay, so we get We'll call it 3.2 since they give us 10.3. It got stretchy. Or else I'm gonna get linear algebra wrong. Oh, sorry, I didn't respond to your thing that's submitted, but that's concerning. Okay. So that's our south component for this vector. The goal is that we want to add everything that's north and south, and we want everything that's east and west. Or, you know, take all the east, subtract off the west. Take all the north, subtract off the south. So, like, the 67.8 vector, it's already straight east. We don't have to do any splitting up. We just got the south part for the vector that isn't split up, and now we can get the west part. So this is especially where a place where you can kind of do it many different ways, but what I'm going to do is draw that right triangle instead, because I know the angle inside there should be 90 minus 71.8, because they should add up to a right angle. So the west component here, the hypotenuse is still 10.3. This angle here is going to be 28.2. Just mentally doing, but okay, let's not trust my mental math here, but it should be that. 90 minus 71.8. 18.2, okay. Wait, I said 28.2. See, that's why you don't trust my mental math. Oops. Okay, so then cosine of that angle is west over 10.3. Do the same thing, multiply the 10.3 over to the other side. Go to the calculator. .8, we'll call it. Great. Okay. So now that all our vectors, we could kind of now draw this as north, east, west, south, except all our vectors are going right along the, like, our northeast, southwest directions. So we have 67.8 east, we have 9.8 west, and we have 3.2 south. So we can take everything that's north, which is 0. Let's say like north minus south. 0 for north minus 3.2 for south. We'll get, you know, this is like minus 3.2 in the north direction, which we can call 3.2 in the south way, which you could also just look at that intuitively and not do this weird math that I'm doing here, but I'm just trying to show you like a procedural way. And now we can do east minus west to get the direction in the east we're going. So 67.8 minus 9.8. Let's not trust my mental math. $58. And that'll also be east because we just have way more east than west here. And we, yeah. So 58 east. Okay, so hey, Akil, am I computer science engineering? I majored in applied math and minor in computer science. I'm not sure what exactly you're asking for, though. Am I a computer science engineer? I guess my answer is no. I know some coding, but that's about it. um, okay, and sorry, I was just like getting a little bit weirded out by how this next part works, but I'm going to draw yet a third scenario here, which is just the results of these vectors. Probability? Kind of, but not really. We're going 58 east, and because we're doing vector addition here, you go like tip to tail. So from the tip of the last one, I'll put the tail and go 3.2 south. The resulting vector that we want is that one in blue. That makes you no wonder you do more real math than the other streamers. So, I feel like most people would feel that I'm doing the fake math and the proof stuff is the real math. But favorite math topic is probably differential equations. Also, yeah. Hi, Matthew. So we just need to get this vector here. We want its length and the angle it makes, I guess, from south to east. So to get the length of the blue, we can do Pythagorean theorem. This is A, this is B. So it's the square root of 58 squared plus 3.2 squared. That's a job for a calculator. Yeah, differential equations are awesome. Square root 58 squared plus I can't type, plus 3.2 squared. Wow, I guess it makes sense. 58.1 we'll call it. And now we need this angle here. I can't get that angle directly, but what I can do is get this angle and do 90 minus that. And so we know opposite and we know adjacent. I mean, we could do it with hypotenuse too, but I want to use tangent here because tangent of that angle is opposite 3.2 over adjacent 58. So we can do the inverse tangent of each side. I can't spell. And that's another job for a calculator. 3.2 over 58. So taking the degrees, I'm going to call it 3.2. And so that's the angle that's inside there. Remember, we want to do 90 minus that to get the bigger angle. So 90 degrees minus 3.2 degrees, that I'll trust in mental math, is 86.2 7.8 degrees. Okay, so all that work to say, we are going 58.1 meters per second in the south 86.8 degrees east direction. So it's a lot of work to get all these components and stuff, but as far as I know, there isn't a shortcut. At least if there is, I haven't done these problems enough to know it. But intuitively, this kind of makes sense because 67.8 straight east is way bigger than 10.3. So I kind of expected it to be pretty freaking east when you add these two vectors together. So if you have any questions, please like let me know. But I hope I made it like followable enough. And then I'm not seeing an immediate response, so I'm gonna start to go back up to the physics I was studying before. But if I see you, oh, okay, parallelogram method instead of component method. I know that intuitively, if you add two vectors together, you can. It's the diagonal of the parallelogram. I don't remember how you use that. We can try to work it out. Or like the result of the addition will be that vector there. Pew. Welcome in. 71.8 plus 90. Opposite angles, cosine method. Lots of cosines often. Okay, I mean we can look at that way too. Let's we'll look at it with a fresh face. So if we make a parallelogram out of these, and take that diagonal, that green vector is the one we want. This angle here is the 90 plus 71.8 that Pew was saying. So that's 161.8. And so the angle opposite here has to be the same. And because it's a quadrilateral, the angles have to add to 360, and we know these two angles are the same. So the measure of just one of those angles will be 360 degrees minus 2 times 161.8, because we have two of those angles, minus 2, I guess kind of like the double bar angle that we want. I'll call it theta. I'm sorry. I'm no. Let me just do it like that. Just subtract off the other two angles, then we'll split that in half. I'm assuming we're going to need those signals, which is why I'm spending so much time on this. 360 minus 161.8 for the law of cosines. Times 2, 36.4. Remember, we have two of these angles, so let's cut it in half. 18.2. So each of those angles is 18.2 degrees. Great. This length is 10.3, 10.3, 67.8, 67.8. Yeah, we only need to do it from one of these, right? We don't need both of these. So if we use the law of cosines here, the law of cosines, maybe I'll draw it out generically here. If you have angle capital C, well, no, you usually use small c, right? Side length big C. The other two side lengths are big A and big B. Big C squared is equal to A squared plus B squared minus 2AB cosine C, small c. And so I'm doing law of cosines with that double angle on the green vector because we want its length. And that's what this will give us. So I'll still call it C, I guess. I'll do it in green. C squared is, we can choose, our choice of A and B doesn't matter, so I'll put 10.3 first. 10.3 squared plus 67.8 squared minus 2 times 10.3 times 67.8 cosine, running out of room, 18.2. And so because this is C squared, we are going to have to square root that. 10.3 squared plus 7.8 squared minus 2 times 7.3 times 6.8 cosine 18.2. Oh, why are we getting different things? Oh, I'm in radians. 58.1. That's the length. Ooh, yeah. So we also need the angle. We can tell just by how the parallelogram looks that it's going to be like pointing somewhere in the southeast, kind of like quadrant. We don't have that convenient of an angle to do it on. I guess we can do it on this angle here. Yeah. If we do it on that angle there, we can use the same trick as we did last time and do 90 minus that. And here I'm taking advantage of the fact that I know this vector up here points straight east. But we want to measure it from south. So law of sines, if I come back to this triangle down here, that's angle A, small a. That's angle B. The law of sines is that sine of A, well, usually I write it flipped, right? It doesn't matter if you flip it. A over sine A equals B over sine B equals c over sine c. I feel like I'm also flipping with which one they use big letters and small letters for, but it doesn't matter. So if I do law of sines on this angle here, which I guess I've been using green, so maybe I should use green. And we can choose any of the other two angles we want. This 18.2 angle looks convenient though, because we don't know what the other one is. That means the side across from 18.2 is the green length we just found. So 58.1 over sine 18.2 is equal to the length across from the green angle is 10.3 over sine the angle we want. So I think the simplest way to think about this is to cross multiply to get rid of the denominators. I'm running out of room. Let me shuffle this down. So if we cross multiply 58.1 sine of our magical green angle, it's 10.3 sine 18.2. And then divide the 58.1 over. .3 sine 18.2 over 58.1. Pew, thank you for the follow. And then we can take the inverse sine of each side. Okay, now we go to a calculator. .3 sine 18.2 over, oh man, I almost remembered this entire thing in one go. 10.3, 18.2, 58.1. .174. That's the same thing we got us last time, right? 3.2. Yep. It checks out. .2 degrees. So remember, okay, so that's nearly the answer, but for the same reason, like this measure is angled from east to south. We want to measure from south to east. So to make that flip, we do 90 minus that. So 90 minus 3.2. I literally just did this a second ago. 86.8. So same result. 58.1, 86.8 south of east, or east of south. South of east. No, east. South 86.8 east. So I guess which one you prefer is a preference, but yeah. No worries, PO, but oh wait, do you know official NAB? Out of curiosity, so official NAB is one who asked the question. Oh, okay. That makes more sense then. So yeah, we have a calc assignment. Oh, nice. Welcome into both of you. I haven't done these problems a bunch, but I know the math, but behind them. in case I'm ever not around and you all need more math help, I know the only one who does this on Twitch. That's a whole list of people right there. It's like get just started. They all do math help in some form. So whenever I see new people here, I just like to let them know that this niche exists. It's not just me. Yeah, I guess good luck with your class though. And thank you for the follow as well. Official name. Oops. No worries. Did you have to do those types of questions a lot, Obi, for your like pre-calc trig classes, like the bearings? 1,200 followers must be out time to invite them over to my place for dinner. I Twitch is just being really generous with that. I'm at 1178. I assume once it gets like 1150, they just start rounding up. I'm sure my one bedroom apartment is gonna accommodate everyone with my non-functional oven. Oh, but DonCon? That rolls off the tongue. Might be worth it just to be able to say DonCon. Okay, sorry, just checking something. Bearings are not very nice considering they're compatible thermal degree radiant, completely different or incomplete a different orientation. It's easy enough, but learning something then changing it for an application is not nice. Yeah, I was kind of fumbling with it, especially at first, because I was like, I know how to do trig and vectors and stuff, but I don't know the best like the most direct way of doing that. Oh my god, what are these emotes? That twerking one is hilarious. Yeah, Territar, that's a mechanics question. I've probably gone through like three different approaches on this one so far. Okay. And I was a pilot for most of the last 20 years, even I just signed before I learned trig. Oh, nice. Not professional streamer. I know. I was just responding to the Central, who was just blowing up my DMs. Can't believe it. The question ramped up. Oh yeah, Tutar, there were some pretty like tough ones that we were doing earlier. Well, I guess I can't say I blame you, Central. Oh, when? Oh my God, Zach's class is in half an hour, bro. When did it get to be this time? I didn't realize we were 4 hours in. Uh, God damn it. That really flew by. Um, can I speed run making dinner before class starts? That's what I'm debating right now. Um, Wait, what? Oh, because so just like taking my attention. No, Central just wants his special time. It's okay. Oh, possessional. Oh. ICX Malol. Thank you for the follow. Probably saying that wrong. To be honest, I just read it as per professional because I assumed that's what he meant. Either way, our sense of humor is giving each other shit. So, um, I think he misunderstood my. Yeah, it's all jokes with Central. I spelled intelligence wrong. Did you? That looks right to me. Use the magic. Oh, okay. I hate I hate leaving this question undone. I feel like this is probably what I need. But I still don't know what to do about the R vector. I don't know how it should be something that's really simple, but I'm kind of confused by it. Oh yeah, what gets me is like words with double consonants. So like the word committee, I think is like this, but like I always get mixed up with whether you double the M's and the T's in like words like that. Yeah. Intelligence. Oh yeah, you're gonna tell just because of D&D, but like some words. Commission. Yeah. Dondo's spelling you. um. I don't know. I'm still debating if I want to like push through to Zach's class or not. I think this problem's gonna. Cause I hate to just leave this problem like partially undone, but I think I'm gonna do it. Yeah, I think I'm gonna cut the stream off now because I completely lost track of time. Embarrassed. Yeah, that's a hard one too. There's just I was just having an issue with that the other day. I forget which word it was though. But just my problem solved are unsolved. Yeah. There you go, Central. Okay. So yeah, I'm gonna cut YouTube channel off here on Twitch. We'll look for a raid. So Territory Nanos is here on YouTube. Thanks for being here. Back on YouTube on Thursday.